My name is Jonathan Stern. I'm a professor of medical statistics and epidemiology at the University of Bristol. And I worked with Matt and Julian and a whole load of other fantastic colleagues to develop the ROB-ME tool. Matt and Julian, do you want to introduce yourselves now, or
Julian Higgins. I'm also at Bristol, Professor of Evidence Synthesis, long-term Cochrane contributor, editor of the handbook, and as I say, Jonathan says, co-developer of this tool.
Yep, and sorry, I'm Matt Page from the Methods in Evidence Synthesis unit at Monash University in Australia. So I previously worked with Jonathan and Julian in Bristol for a few years, but have been back in Monash since, and look forward to presenting this tool to you.
thanks. And Matt, if we could move to the next slide, please. I mentioned the collaborators, and the key collaborators are listed here. They all made huge contributions, and we're grateful to all of them. Next, please. So the idea that the results of research syntheses and meta-analyses might be biased because of failure to report all the research that's been done is a pretty old one in the discipline, going all the way back to a book on the science of summing up by Light and Pilmer. And the broadest description of the idea is that we can get bias arising from non-reporting of study results when decisions about about whether, when, where, or how to report results are influenced by their results, often the p-value and specifically statistical significance, or more generally the magnitude or direction of results. The non-reporting may involve non-reporting of whole studies where the main result was considered to be statistically non-significant, or it might be non-reporting of some results, even when the study is at least partially reported. And fairly obviously, if some results are not available for meta-analysis, and their lack of availability is related to the nature of the results, that can lead to bias in the meta-analysis. Next, please. Now, all the way back when Light and Pilmer introduced this idea, they proposed that funnel plots, which are simple scatter plots of some measure of a study's size on the vertical axis against the result on the horizontal axis, they proposed that funnel plots could be used to diagnose the presence of publication bias, or more generally non-reporting bias. And I think it's fair to say that two problems arose from this. Firstly, funnel plot asymmetry, which is the diagnostic the proposed diagnostic for the presence of non-reporting biases, became equated with publication bias, and there was too little focus on other potential reasons for funnel plot asymmetry. And the second problem was that as the years went by, we became aware that there were wider considerations that might enable us to say something about the potential for bias due to non-reporting. So the issue of publication bias became too wrapped up in the issue of asymmetry of funnel plots. Next, please. After the seminal work that was done by An-Wen Chan and Doug Altman and colleagues, it was realized generally across medical research that selective reporting of results within studies was a really important issue, and that there was too little focus on that when we were considering the potential for bias due to missing evidence in meta-analyses. So sometimes we may know that here study 6 was conducted and we may know something about it, but the result for a particular outcome may not be available. And there wasn't a good way, we didn't think, of integrating issues of selective reporting of results with issues of non-reporting of whole studies. And the discipline moved on in other important ways. Prospective registration of trials, while not ubiquitous, is widespread these days. And that means it's possible to identify that there are potentially relevant studies for which we don't have results in a way that wasn't possible when the proposal was made to diagnose publication bias using funnel plots. Next, please. So the aim in developing the ROB-ME tool was to develop a transparent and reproducible way to assess risk of bias due to missing evidence, where one considered the results of the meta-analysis in the context of what one knew about the missing results, and then assess the whole meta-analysis as being at low risk of bias or having some concerns, or a high risk of bias due to missing evidence. Next, please. And that led to the development of the ROB-ME tool, which we're talking about this morning, and which is a new tool for integrating assessment of risk of bias in meta-analyses due to missing studies, that's publication bias, or missing study results, that's selective reporting bias. The tool is primarily designed to assess meta-analyses of the effects of interventions, and is likely to work best when we're dealing with meta-analyses of randomized trials. Its development was informed by a review of existing tools. Matt and colleagues published a widely cited paper in BMJ Open in 2018 by expert consensus and through piloting before the final version was published. Next, please. So the full publication of the tool came in this BMJ paper last year, and that paper describes both the development of the tool and its main features. Next, please. However, as with all of the risk of bias tools that our group developed, the best place to look is on the website. So when we make minor changes, we make that available online. And the ROB-ME tool can be found at the website riskofbias.info, as can latest versions of the other tools, ROB2 and Robbins-I and Robbins-E. Next, please. The other relevant place to look is chapter 13 of the handbook. That was originally published before the ROB-ME tool was finalized, but it's been updated to present the tool online at the URL shown at the bottom there.